All right, so the 6-7 notes, those are the last set of notes that are going to be in the rational functions unit. These are going to go on page 85 whenever we're finished. And it is about transformations, and we already saw some transformations of rational functions over the last few days. What kind of transformations did we see? Shifting, right? In what direction? Left or right, and then also up and down. That's right. So we're going to throw that back in there today. It's going to be where we start because we've got some experience with that. And then we're going to talk about the other types of transformations, which are reflections and scale changes. So vertical stretches and vertical compressions. But in order to talk about all of that with transformations, we want to talk about the parent function first. And your 6-1a notes discuss the parent function. It's a fraction because it's rational. We have intercepts, and I'm not going to pass out rubber bands again, but I am going to get one rubber band for the screen. So the vertical asymptote is right here, correct? What's the equation for the vertical asymptote? What equals 0? X equals 0. Good. So I'm going to go ahead and write that here. And then for the horizontal asymptote, y equals 0. Very nice. So it goes through the y value of 0. Okay. The domain is all of the x values from left to right, and it goes from arrow to arrow, so we should start out with all real numbers. However, there is a value of x that we can't have. What is that? 0, because what's at x equals 0? An asymptote. So because of the asymptote, there's no part of the hyperbola that can have an x value of 0. So the domain is all real numbers with x not equal to 0. Remember that whenever we originally found the domain in our notes, our domains were always all real numbers, but we would take the denominator's factors and we'd set them not equal to 0. So it's kind of like the same thing. X is not equal to 0. And then the range, same idea, just the y values from the bottom to the top. Range is what? Bless you. All real numbers, except what? Y is not equal to 0. Yeah, because y is the range values. Very nice. So we're going to kind of refer back to this every once in a while. The transformation format, like where things go in the function, is here. So you might want to, box this, put a little puffy cloud around it, maybe some stars, something to show that this is important and this is where you're going to come back and look when you have transformations. This is how you're going to figure out where they belong. Yes, sir. That's a really good question. Do you need to memorize it, or is it going to be on a reference sheet? I don't believe it's on a reference sheet. In fact, let me pull out the math chart for Algebra 2. It's in my notebook at the very beginning. And I'm just going to kind of scroll. Bam, yeah. I don't see it anywhere. So no, this is not something that's going to be on a formula chart. It is something that you're going to have kind of memorized. I mean, I'm not going to ask you to write this down, but I am going to ask you, like, what these things might do. Yeah, H and K and A and what those things might do. In fact, let me cover this up. When we talk about transformations in general, if I have something that is in parentheses with x, maybe I have x minus 3, what kind of transformation is that? It's shifting positive 3 to the right, yes. So inside the parentheses with x, that shifts horizontally, and then whatever's in parentheses is a lie, right? It's the opposite. Where is x in the parent function? It's in the denominator. So if anything is shifting horizontally, and it's got to be with x, connected to the vertical asymptote, yes. Yes, you are absolutely right. But the point is, anything that is shifting left or right has to be with x, which means that we're going to have this x minus h in the denominator. So this is the part that shifts left or right. What does this do? Shifts up or down. This is a vertical shift. Very nice. And it's just like it always is. It's hanging out on the outside. It's what you add or subtract as the constant at the end. And then the A value is the scale changes. So this is the vertical, stretches and compressions that you've seen before. And it's all in the same spot. It's always plus K on the outside and times A in the front. And the H is always with the X, and it's always the opposite. Like, it's all the same things. The only difference is this is in the denominator now because it's a rational function. So I'm going to move this down a little bit. Let's talk about the changes that are happening. So the previous problem that we had was the parent function, and the vertical asymptote, it was this, but now you're right. It's what equals -3. X equals -3. So what has happened transformation-wise? Shift what? Left. Left 3. And then I heard something else. Also shifted, up 2. Because the horizontal asymptote used to be y equals 0, but now the horizontal asymptote is y equals 2. It's been shifted up 2. I agree. So, we already talked about how the vertical asymptote was x equals -3, and the horizontal asymptote was y equals 2, absolutely. But we do need to fill in, before we do domain and range, we do need to fill in the function. Okay, so these have been shifted. Now I'm going to include this on the screen up here. If I'm shifting left 3, where does the 3 appear in the function? On the top? On the bottom, right? And instead of x minus h, what should I have here? X plus 3. Good. So 1 over x plus 3. And then how do I write in my shift up 2? Plus 2. Good. On the outside. Very nice. Yeah. Good job. Could you take a moment to write the domain and the range? Please try that. I'm going to pause the video. Are you getting homework over this? Yes. Yes, it'll be due on Tuesday. And I think you'll be doing pretty well with it because 4th period started it and a lot of them almost finished it, even within a small amount of time. So the domain. Ulissa, what did you get for your domain? X does not equal -3. Good. I like that you caught yourself. Can't equal that vertical asymptote value. And then the range, look and see what you put for the range. Jillian, what'd you put for your range? Y is not equal to 2. Good. That horizontal asymptote cannot have a value for the hyperbola. Very nice. Yes. To be clear, yes. Meaning if there are 2 vertical asymptotes? Yes, if there are 2 vertical asymptotes, then you're right. Both of those numbers appear in the domain as x values that you can't have. Yes, ma'am. Good question. All right, let's open this up. Let's go to the inside. The shifts are not that tough. Those are the easier ones. So now we need to talk about the other types of transformations, and the next thing that makes an appearance is a reflection. So I'm actually going to do a side-by-side of the front of the notes and then the reflections. Okay. I'm going to try and hold these in place. So this is the what? This is the front of the notes, so it's the what? What is this the function of? This is the parent function. Good. This is the rational parent function. Notice that the hyperbola occurs in the top right and the bottom left. So that would be quadrant 1 and quadrant 3. Yeah, quadrant 1 and quadrant 3. This does not have a hyperbola that's happening in quadrant 1 and quadrant 3. The quadrants that it's taking place in is 2 and 4. That's right, it's different. So that means that you have an A value of -1. You have a reflection across the x-axis. What's happened is that this part that's in quadrant 1 has been reflected over the x-axis and is now in the bottom. Do you see that? And this part that was in the third quadrant, it's been reflected over the x-axis, and now it's in the top left. Do you see that? So if you happen to see a hyperbola that doesn't have the hyperbola in the first and third quadrant, that means that you have a reflection that's happening. And I guess it isn't strictly in the first and third quadrant, because if you shift this left or right or down or whatever, it would be in different quadrants. But I'm talking about if it's not in the top right and the bottom left, then you have a reflection. Okay, so I'm going to move this over to the side. Has the hyperbola been shifted at all? No, I know the hyperbola hasn't been shifted because where's the vertical asymptote? What equals 0? X equals 0, that's right. And what's the horizontal asymptote? Y equals 0. So that means no shifting has occurred, but we have a reflection. So the description should be reflection over x-axis. Reflection over x-axis. Let me address those questions in order. Your question was, is it just a reflection? Because there's no change in asymptotes, that's right, and there's no other change in a value, which we'll get to in a second. So yeah, just a reflection. And then the other question was, domain and range are the same as they were in the parent function, right? Yeah, nothing else has changed about them. So the domain is all real numbers, except x cannot be equal to 0, and the range is all real numbers, except y cannot be equal to 0. Very nice. Do you need a little bit of time to have discussions in your group and kind of come up with questions? Yes. Yes. Oh, that's a good question. How do you know if the graph reflects across the y-axis? So let me ask you something, again, kind of double screening this. If my parent function reflects across the y-axis, this goes over here, correct? Doesn't it show up here? And then this would go over here. Does it show up here? It kind of looks like the same thing, right? We're not going to talk about y-axis reflections for this today. Not never, just today. We're not going to talk about them. Yes, ma'am?
Can you have a g of x if everything's 0?
Can you have a g of x? Yes, because this is a good example. Both of the asymptotes occur at 0. X equals 0, y equals 0. The domain has all real numbers except those values can't be 0. So we have that situation here, but the g of x is the function that's been translated from the parent function. So what's the description of the transformation that happened? It's a reflection over the x-axis. So the only thing that changes is this, is the a value of -1. So if hang on, let's get everybody on board. Hang on, don't go too fast. If I try to write my g of x, what is the a value? -1. Do I have a h and a k value? No, it's just this out in front that needs to be -1, right? So how do I write my new transformed function? -1 parentheses 1 over x. Is there a different way that you might be able to see this? Just -1 over x. Both of those ways could be something that you see, yes. And that's the only thing that's different from the parent function, because the only change that happened is the reflection. Okay. All right, let's go talk about scale changes. So stretching and compressing. Do you remember, I'm gonna override this again. Do you remember when we talked about transformations with parabolas? And we talked about the parent function, which has, for a parabola, has a vertex of what? 0, 0, correct? And if I were going to graph the parabola, if I went to the right one, how much would I go up? 1. Up 1 over, or sorry, right 1 up 3, yeah, and then right 1 and up 5 and then 7, yes. So all those odd numbers. So that was how we made the parent function for a quadratic. Whenever we were determining if there was a scale change, so a vertical stretch or compression, the way we figured that out is, let's say I have this parabola. The smaller one is just a transformed parabola, a different one. So if I were trying to figure out what the a value is for this dashed parabola, I would go to the right one and I would see how many I have to go up to get back on the parabola. So what is the number that I have to go up? 2. So what is a equal to? 2. So when I went to the right one, a was how many I had to go up to get on the parabola. Same situation here. If I go to the right one, how many do I have to go up to get onto the hyperbola? 2. So what's the a value? 2. So if you start from the intersection of the asymptotes and you go to the right one, it's that distance that you have to go up, yes. So because that distance is 2, and you might want to draw this in your notes, that's where the 2 comes from, where the a value comes from. Yes? You mean like, let's say I have to go up 4? I'd go to the right one and I'd count up 1, 2, 3, and if this was on my parabola, then I'd say my a value is 4. Oh, that's not something that we are going to talk about today. A is the difference from the intersection of the asymptotes, because remember, they could be shifted, like left, right, up, or down. When you go to the right one, it's how much you go up. When you go to the right one, it's how much you go up. That's the a value. So in the second example, if I start at the intersection of the asymptotes, and I go to the right one, how much do I go up to get on the hyperbola? A half. So what's the a value? A half. No, you can't just pick any point. You start from the intersection, you go to the right one, and it's how much you go up. You start from the intersection, you go to the right one, and it's how much you go up. So if my a value is a half, and my a value needs to show up in the front, then raise your hand if you can tell me how I can write my transformed function g of x. Yes, sir. What is the function? 1 over x. Good. Is there a different way that you might see this? 1 over what? 2x. Yeah, you might see it that way. And I know we didn't write the function g of x for that vertical stretch scale change, but if I were to write this out in front, 2 times 1 over x, And if I were to really multiply these together, where would the 2 go? On the top. So you could also see this as 2 over x. Because 2 can be written as 2 over 1, and it becomes the numerator. So numerator times numerator is your new numerator. Because 1 over x is the parent function for a rational function. Yes, ma'am? Can you write it either way and still get it correct? Yes, ma'am, but you need to be able to recognize either way if it's given to you. Okay? All right. So I'm going to flip this over. We may or may not have time to do a full one. I don't think we're going to have time to do a full one, so we might have to pick this up tomorrow. Monday. Monday. Yes, Saturday, I know. All right, so whenever I write the h and the k values, h and k used to be the vertex of a parabola, but now it turns out that it's like the center of this hyperbola. So what is the h value? Or better question, what is the vertical asymptote? What equals 2? X equals 2. So how much is my hyperbola shifting? 2 to the right, so where does that fall? Which number is that? It's H. Okay. Where is the horizontal asymptote? Y equals 4. Thank you for giving me the full equation. Y equals 4 is the horizontal asymptote, which means that the hyperbola is shifted 4 units up, and that's a K value of 4. Remember, K is the amount that you go up. To find the A value, where do you start? Shh. Side conversations need to stop. When you're finding the A value, where do you start? Not the origin. The intersection of the asymptotes. How many values do you go to the right? 1. And then what do you do from here? Count up. So 1, 2, 3. What is your A value? Not 1 over 3. Just 3. It's the amount that you go up. So how much you went up. After going to the right one. So I'm going to go ahead and pause the video here because the bell is going to ring soon. We'll pick up this example on Monday, and I'm going to pass out your homework. Oh, we do end at 55. Fantastic. Okay, good. Thank you very much. All right. I know, sorry. Okay, so for the rational function, I'm going to pull this to kind of do a side-by-side. So I need to start out with what, Nathan? G of x equals? What needs to go first? 3, the A value. So 3 comes out in the front. Times 1 over x what? Minus 2. Good. Close parentheses, and I end with plus 4. Very nice. The domain is all real numbers. However, the x value cannot equal what? 2. And the range is also all real numbers, but the y value cannot equal 4. Okay. The only thing, folks, side conversations need to stop. This is the last warning that I'm going to give you before I assign detentions. And they're going to be detentions on video, so that's going to be embarrassing. Don't do that. So we want to rewrite as a single fraction, and what I'm rewriting is this. This is the only thing that I think you might struggle with because it comes from the stuff at the beginning of Unit 6, and I know that that stuff was a struggle. So I need to rewrite this as a single fraction. Can you find a better way to write this? Where should this go? On the top, right? So I should have 3 over x minus 2 plus, how do you write 4 as a fraction? 4 over 1. But I don't want it to be 4 over 1. I want it to be something over what? X minus 2, because when you add fractions, you can't do it unless you have a common denominator. An LCD, that's right. And the least common denominator for 1 and x minus 2 is what? X minus 2. 1 times x minus 2. So if I want an x minus 2 down here, you're right, I also have to put it on top. This is from the kind of the beginning of Unit 6. So now, the denominator is just what? What's the common denominator? X minus 2. And the numerator is created by the 2 previous numerators joined with that operation in the middle. So it's like, it's not 7x minus 2. Because for PEMDAS, that 4 is being multiplied and added. This is a stronger operation than the addition is. So the addition kind of has to wait. It wouldn't be 7. No, it would be 3 plus 4x minus what? 8, because what do you have to do with the 4? You have to distribute the 4. Thank you. So, your final answer still has x minus 2 in the denominator, but you have like terms that you can combine, so you have 4x minus 5. Because 3 minus 8. The question is, do you have to do it on every problem or just some problems? You only have to do it if it asks you to rewrite as a single fraction, and it's not going to ask you on every problem.
And whatever the x minus 2 on the bottom is, that's how you know to add it to the other 2?
Up here also? Whatever you insert on the bottom, yes, you have to also insert on the top. Yes. Okay, so I'm going to move to example 2. Notice that example 2 doesn't ask you to rewrite as a single fraction. So that's an example of not having to do it every time. So I'm going to pause the video. I'm going to let you find all of your answers. This is a great time to try out every type of key feature. Try to find everything. If you mess up, who cares? Because it's not a test. You can just erase it and redo it because it's notes. So let me pause the video and let you fill in your stuff.